Hello students, and welcome to this new video where we are going to today go full linear modeling. We're going to talk about mixed models, ANCOVAs. So we're going to have repeated measures factors, we're going to have group factors, and we're going to have interval predictors, also called covariates. Let's give a little context here. So researchers are doing a program evaluation involving two potentially interacting interventions to enhance quality of life among school children. The initial level of quality of life is recorded first, and their resistance against the intervention is evaluated by the researchers. So in other terms, we will have a pre and post measure of an outcome, that is quality of life. We are going to have two interventions, right? So treatment 1 and treatment 2, that is going to be two group variables. And we're going to have a covariate, interval level predictor, that is the resistance against the intervention. So here is the research question. Controlling for resistance, which treatments or which treatment is or are efficient? And a supplementary question here is, do the two treatments interact? In other words, if we have both treatment 1 and treatment 2, do we only have an addition of the effects of treatment 1 and the effects of treatment 2, or do we have an interaction, meaning that maybe the fact that there is treatment 2 would reduce the effect of treatment 1, or would enhance the effect of treatment 1, for example? Right, so that is the question of the researchers, and let us now directly switch to SPSS to have a look at the data here. So what do we have? We have quality of life before the intervention, that is an interval outcome. Quality of life after, right? That's the same outcome, but that's a second measure. So here we have a repeated measures design, also called a within factor, that is time, basically. And here we have intervention 1, intervention 2. These are two nominal variables. So we have zeros and ones, 0 for individuals who did not have intervention 1 or intervention 2, etc. Here we have an individual who has had intervention 2 but not 1, and here intervention 1 but not 2, and here the two interventions. Right, so we have all the different situations here. And finally, we have our covariate resistance that we just want to control for. We don't formulate any hypothesis on it, but we know that it may change the way interventions are perceived and their efficiency. The possibility that some individuals may be more or less resistant to interventions. Right, so let us directly get to the analysis here. So let's click on Analyze, scrolling down here, General Linear Model, and we will select the repeated measures here, right, repeated measures. All right, so we have this dialog box popping up. What do we see here? SPSS basically asks for a within subject factor name. Well, what is our within subject factor? Here we have repeated measures over time. Right, so let's call it time. And how many levels do we have? We have a pre and a post, so we only have two levels. We only have one measure here, we only have quality of life, but in some cases we may have multiple measures. For example, we may have quality of life, we may also have measured anxiety, we may also have measured stress, etc., etc. Here, if it were the case, we could add here different measure names here. Here I only have one, so I don't necessarily need to do what I'm about to do here in a few seconds. But if I had more measures, of course, I would be forced to do that. So here, let's just call it quality of life, and let's add it. But because there's only one, it's not necessary to do that. Let's click on Define. Right, and now we get into the standard ANCOVA, repeated measures ANCOVA dialog box here. So we have our within subjects variables, that is here defined as time, as we just defined. So we have one first level that actually corresponds to quality of life pre. So we're going to here put quality of life pre here on the 1. We could, by the way, let me reset, but we could also simply select it and then click here on the arrow. And the second level of time is, of course, here post, the quality of life post treatment. Right, so that's it for the within subjects. Now we have our two group factors, right, between subjects, right? So these are differences between subjects. They either took intervention 1 or did not take it. So we have intervention 1 and intervention 2. Let me just click on shift and select the 2, or you can of course add them one by one, intervention 1, intervention 2. Finally, here our covariate, which is our interval predictor. We don't have any hypothesis on it, but we want to control for it. So let us select it and include it here in this covariate box. Right, so we have all set up here in the different variables, but as you know, when there are many variables, there can be different designs. And so we may want to select the different terms in the model here. We will not need to change anything because the default that SPSS does is that it's going to test, let's say, let's call it a classical experimenter's hypothesis. That is that the intervention is going to have an effect on the increase over time or decrease over time of quality of life, the change over time of quality of life. So we're going to have we are going to have, of course, the main effect, so time, intervention 1, but we're going to have the interaction of intervention 1 and time, right? And so that's going to answer the question of does intervention have an effect on the increase or decrease or change in general of quality of life? Same thing for intervention 2, and we're going to add, of course, resistance in the model between and within subjects. So that's what it's going to add, just to control for it. But also it's going to, by default, add in the model the interaction of intervention 1, intervention 2 over time, right? So how does having both intervention 1 and intervention 2 it can be a changer that is different than the mere addition of intervention 1 and intervention 2. So it's going to add this three-way interaction of the within subjects time, intervention 1 and intervention 2. Right? But for example, one term that it will not by default add, but that could be interesting to investigate, could be the interaction of resistance with intervention 1 over time. For example, we may think that resistance plays a different role in intervention 1 than in intervention 2, for example, right? So we may add this this new interaction, but here we don't have any hypothesis on it, so we are not going to do it, right? But basically, you can customize this model here. Let's click on continue. So let's not change a thing. Full factorial. Let's click on continue. All right, what else could we want to add? Let's click on plots, right, so on plots. One thing that is very interesting is to have a look at the effect of each intervention over time, right? So let's have a look at this interaction of intervention 1 over time by adding time here as the horizontal axis and intervention 1 as separate lines, right? Lines of different colors if you prefer. And of course, the dv here, the y-axis, is going to be quality of life. So let's click on add. Right, so we'll have this plot. Let's add a new one that's going to do the same thing, but for intervention 2. So time is going to be on the horizontal axis, intervention 2 on separate lines. Let's add it. And finally, let's try to see if we can see an interaction through plots. It's not going to be very something very easy to see, but let's see how intervention 1 works over time in the group that does not receive intervention versus in the intervention 2 versus in the group that received intervention 2. So in other terms, let's create a layered plot with still time as a horizontal axis. Let's, for example, select intervention 1 as different lines, but let's compare it in the different groups of intervention 2, right? Let's compare it for individuals who received intervention 2 and for, let's compare individuals who received intervention 2 versus individuals who did not receive intervention 2. So time, intervention 1 and intervention 2, and there we have our three-way interaction of within, the within factor and the two between subjects factors here. Right, let's click on continue. Another thing that we may want to do is save the residuals to check for their normality. I'm not going to do it here, but we basically would do the same analysis as in multiple regression. Another thing that we may want to do here, if we click on options, so I clicked on options, is we could display the different means that were just plotted. So here we could see the effect of intervention 1 over time, the effect of intervention 2 over the difference between pre and post, right? And we could see here the interaction of the two and its effects over the difference between pre and post. So let's add these, but let's note that it's going to be a bit redundant with our graph. Another thing that we may want to do, here these graphs will always show the means that are called marginal means. They will control for resistance, right? So they will sort of fix resistance and use a fixed value of resistance and compute and estimate these means. But they may not correspond to the same means as we would have had without this covariate. So a good first step is to just have a look at the descriptive statistics first to see what is going on, putting aside this covariate thing. Of course, I'm always encouraging that. Always report estimates of effect size as much as you can. It's not always perfectly possible, but here in the case of linear models, we have a simple estimate of effect size that's called partial eta squared, right? So we want to report that, not just the significance. We could here have the observed statistical power. We'll not select that. Let's just focus on the basic, most important things. Another thing that we could add is the homogeneity test. So basically Levin's test that would compare variances between error variances, between the subgroups. Also, it would report boxes M, test the homogeneity of the covariance matrices. So basically what it will do is check for the homogeneity of regression slopes. Let me clarify that. It means that in such models here, for example, we are making the assumption that resistance is correlated with quality of life in the same way in all the subgroups, right, and in all the measures. So we may want to check for the homogeneity of such correlation among all of these different measures, and that's what we would check using one single test that is called boxes M, and that's something that you can see here. But if you check this box, but I'm just going to focus here on the essential things here. So let's click on continue, and that's it. Let's click on OK and see what we have. All right. Okay, a lot of things, right? A lot of different plots, a lot of different tables that we have. So let's just first have a look at the beginning of the output. Right, so this is, well, not very useful. We already know that. That's the N for intervention 1, 0, or 1. So for individuals there are 100 individuals who did not take intervention 1 and 100 who did take it, and same thing for intervention 2. And basically here you can see also that we have 50 people in each combination, right? So we have an equal subsamples design, an equal subgroup design. So we have 50 people who did not have any of the interventions, 50 who had intervention 2 only, 50 who had intervention 1 only, and 50 who had both. Right, and here we have reported the different means, right? So this is pre, this is so at the pre-test. So what we can see here, if we just had a look descriptively, we can see that more or less they all have basically around the same mean here, of about 20. But at the post-test, that's where we see differences. For example, here in quality of life, when you don't have any intervention, you have you seem to have a mean of around 18. But if you had, for example, here intervention 2, you have a mean of about 22. If you had, intervention 1, you had a mean of about 20. And if you had a mean of, if you had the 2 interventions, you have here a quality of life of about 30. Right, so it looks like the treatments, it looks like the interventions are actually enhancing quality of life. So let's check that a bit further here. let us have a look at the within subjects effects here, right? So basically what we want to see is if intervention 1, for example, is going to have an effect on the increase or on the change over time of quality of life. So when we ask about the efficiency of intervention 1, we have to look at the within subjects interaction between time, sorry about these pop-up things here, the interaction here between time and intervention 1 and the within subjects effects. Can we assume sphericity? We can, because there's only two measures, and that's why basically you always have here the same values, and you can see that because we only have two values, here we have a Moschli's test of sphericity that is really useless, right? There is no sphericity to check. Sphericity is only there to be checked when there are more than two repeated measures. So here, let's not care about these different lines, they're all the same. So sphericity assumed, so let's of course assume it. Here what we see is that we have a significant effect of intervention 1 over the increase or the change over time of quality of life. So bottom line here, intervention 1 has an effect here. And you see that it's pretty large. But not as large, for example, as intervention 2. We see the same thing here, so we have a significant effect of treatment 2. So what we can say here is that intervention 1 had a significant effect over the change of quality of life, and intervention 2 also had a significant effect over the change of quality of life. Now what about the interaction of the two? So the interaction of the two treatments can be seen here. So what happens when we have both interventions? Is that different from just an addition of the two treatments? Well, it is, right? So what we can say here, there are different ways to explain that, but what we can say, of course, is that we have a significant interaction between the two treatments effect over the change in quality of life, right? And we see that because of the p-value here. That's the p-value, and here we have partial eta squared. And there are different ways to say that, but there are basically two ways to say that. We can say that the effect of intervention 1 is moderated by the presence of intervention 2, or we can say the opposite. Basically what it means is that when you have both treatments, right, when you have both treatments, the effect of intervention 1 is different. Right, significantly different. But you can also say that when you have both treatments, the efficiency of intervention 2 is different, right? And here, of course, we suspect, because of the means we have just seen earlier, we suspect that actually when you have both treatments, it's even better than the mere addition of the effects of these two treatments. So let's really have a look at what happens here. Let's scroll down and have a look at the different plots, so we can see what is really going on here. So here we have these two plots, and here what we have is time, and here the dv, right? So that's before, after, and we can see here that intervention 1, so that's the green line, right, seems to result in really an increase, right, of quality of life, right? So that's what we saw earlier about the effect of intervention 1. Here we see that intervention 2, right, all things being constant here, intervention 2 seems to have here, trigger a great increase in quality of life, whereas individuals who did not receive it didn't change much, and they actually had a slightly lowered quality of life. And now let's have a look at the interaction between the two. So here we will have a look specifically at individuals who did not receive intervention 2, and we will compare that with individuals who did receive intervention 2. Right, so let's have a look at individuals who did not receive intervention 2. So they had here, actually a decrease of quality of life in both cases. However, what we can see is that there is still an effect, a good effect of intervention 1, in that it has reduced, right, this dramatic decrease. It's not so dramatic if you have a look here at the scores, but here we have a decrease of quality of life if you did not receive intervention 1, but it's not as large for individuals who did receive intervention 1. So intervention 1 here had an effect in sort of calming this, this decrease in quality of life. And now the question is that different? Is what we see here different? This difference between, this interaction between these two, this difference between these two slopes, is it different in that case as in that case? Right. So here also we see a difference of slopes, because we see that over time, basically, the participants, whether they received intervention 1 or not, had an increased quality of life. But what we can see is that the individuals who did receive intervention 1 had a much greater increase, and as you can see, that's almost 10 points here. And here, once again, our three-way interaction between time, intervention 1, and intervention 2 shows that the difference of slopes here is significantly different than the difference of slopes here. So in other terms, here what we see is really a dramatic increase due to intervention 1 in the case where individuals received intervention 2. And it's not necessarily something that is very clear to see on two different graphs. The reason for that, and that's probably a bit stupid, is that the two graphs are not scaled in the same way. If you have a look here, it goes from 18 to 32, but here it goes from 17.5 to 20.5. So here this looks maybe very dramatic, but it's actually scaled differently. And here what we see is a much greater difference between the two. And that's also something that we already saw in the descriptive statistics, but also something that you can see in this table, is that when individuals actually received both intervention 1 and intervention 2, they had a much greater score here, a much greater score of quality of life. So it basically means that the interaction of the two is even makes the fact that they receive the two treatments even more beneficial than the simple addition of each treatment. Right. So thank you for watching this video. So basically, the bottom line here is that we had an effect of intervention 1, we had an effect of intervention 2, and we had an interaction effect of the two over the change over time of quality of life. And so, what recommendation could we make from this from these results is that well, intervention 1 is going to be beneficial, intervention 2 is going to be beneficial, but really having individuals take the 2 will be the best solution to offer here. Thank you for watching this video.